Hello friends, welcome to my channel. So today we are going to learn how to use Apache Spark in Microsoft Fabric, right? And in this we are going to learn configure Spark in a Microsoft Fabric workspace, identify suitable scenarios for Spark notebooks and Spark job, use Spark data frame to analyze and transform data, use Spark SQL to query data in tables and views, and visualize data in a Spark notebook. But before jumping into all these topics, first of all, let's discuss that. What is Spark and why do we need it in the first place here in Microsoft Fabric, right? So, why are we learning this Microsoft Fabric? Isn't it for data analytics workloads? And then here we are going to analyze the data, the huge amount of data that is there everywhere, right? So we have to use the huge amount of data which is there in the system, which is coming from various different sources, and then uh, we have to analyze this huge amount of data. So in order to analyze this huge amount of data, Apache Spark uh, comes in handy basically. But what is so special in Spark? So just take an example. Suppose we have a huge amount of data, or we have a very huge a file, right? So consider this is a huge amount of data set. Now uh, if you have one system, and then it has a limited capacity, right? It has a limited amount of storage, and then few GBs of RAM, right? So if this file would have been a small file, then for one computer it was easy to do the processing, right? But in case the file size is huge, if it is in billions or trillions of rows are there in one single file, do you think that it is possible to process this huge amount of data in one single system? The answer is no. So what is the solution for this? So the solution for this is that this huge file is actually divided into several small files. So just think that this huge amount of file is now broken down into small files, right? So the blue boxes are now has is the small parts of this big huge file. And now this each small part will be sent to individual machines. Okay, so just think of it as these red ones are the individual machines now. So earlier, traditionally, what we were doing, we were just doing all the processing in one single machine, right? Where the amount of data was small. But in this case, we are breaking this huge amount of data into small parts, and then sending these small parts into individual systems, right? So these small files will go to these individual systems, or you can see machine computers itself, or the virtual machines, and then these individual machines will do the processing of these small files. And the best part is all this processing happens in parallel, right? And this is the reason how this huge amount of data is being processed within seconds, right? So here is where, so this is what Spark actually does. So Apache Spark is nothing but an open source system, and then it processes the huge amount of data. Um, so yes, so let's go to the different modules that we have, right? So let's go to the first module of this. first unit of this module. So let's go to introduction. Before that, let me clear this up, right? So yeah, and we will go to the introduction. So Apache Spark is an open source parallel processing framework for large scale data processing and analytics. Spark has become popular in big data processing scenarios and is available in multiple platform implementation, including Azure HD Insight, Azure Synapse Analytics, and Microsoft Fabric. So this module explore how you can use Spark in Microsoft Fabric to ingest, process, and analyze data in Lakehouse. While the core technique and code described in this module are common to all Spark implementation, the integrated tool and ability to work with Spark in the same environment as other data services in Microsoft Fabric makes it easier to incorporate Spark-based data processing into your overall data analytics solution. Meaning, so everything wherever we are using this Spark technology in other cloud technologies or other cloud environment as well, right? So everything is common there. So the only thing is in Microsoft Fabric, uh, we have all the tools available in one place only, and then we in data analytics framework, we have to use different tools at different places, right? So in data engineering, we have certain tools using which the data engineer builds the data. And then in data analytics part, there are certain tools which a data analytics engineer is going to use, right? And similarly, the business intelligence engineer is going to use certain tools to visualize the data. So in Microsoft Fabric, we have been provided with all the tools in one single place, right? So here we are going to learn how we can use uh, Spark technologies, right, for processing the huge amount of data within Microsoft Fabric. So let's go to the next unit. So prepare to use Apache Spark. So Apache Spark is a distributed data processing framework that enables large-scale data analytics by coordinating work across multiple processing nodes in a cluster. Put more simply, Spark uses divide and conquer approach to process large volume of data quickly by distributing the work across multiple computers. So this is what we were discussing right in the beginning of this session, right? So the process of distributing task and collating result is handled for you by Spark. You submit a data processing job in the form of some code that initiates a driver program which uses a cluster management object called Spark context to manage the distribution of processing in Spark cluster. So earlier in the beginning of the session, we have seen that how the data has been distributed, right? A big file is broken down into small parts or a small files, and then it was distributed across multiple systems. So this is all being managed by a cluster management object called Spark context, right? So it is kind of a driver program, and then it takes care of the distribution of the data across multiple machine and then processing it in the Spark cluster, right? So mostly these details are abstracted, meaning that it is not visible to the user that what is happening at the background, right? But yeah, just to know, you should this information would be handy actually, so that you are aware that how it is happening behind the scenes. Okay, so as an analytics engineer, you are just going to write the code, okay, to perform that operation that you want to achieve, right? You can just write the code, but behind how it is actually doing the operation, that once you understood that, I think that will make more sense that how it actually works, right? So Spark can run code written in a wide range of languages including Java, Scala, Spark R, Spark SQL, and PySpark, right? So most data engineering and analytics workload are accomplished using a combination of PySpark and Spark SQL. So just a moment. Yeah. So yeah, in settings. So in Microsoft Fabric, we start working by creating the workspace, right? We create a workspace. Under that workspace, we create the lake house, and then we create the tables and all, right? But each workspace is assigned a Spark cluster, right? So whatever processing that we are going to do, by creating a notebook and whatever, whenever we are going to use the Spark, a, a Spark cluster is being assigned to that workspace, right? So that setting can be done by the administrator, right? And then once we go to the workspace setting, there, if we go to Spark Compute, here we can see that uh, we can set the node family, we can set the runtime version, and yeah, I think these three, and then Spark properties, right? So these three things we can manage as an administrator, right? So uh, there there are certain settings which are by default set, okay, and yes, this will give the optimum performance for the users, right? So in most of the scenarios, the default settings provides an optimal configuration for Spark in Microsoft Fabric. Now coming to libraries, so we have already the pre-defined libraries, right, as an open source, and then whenever we are writing the Spark code, right, we can use these available libraries for taking out, for doing any operation. So yeah, so let's go to the next unit. So run Spark code. How are we going to run a Spark code, right? To edit and run Spark code in Microsoft Fabric, we can use notebooks, and we can also define a Spark jobs. So notebooks uh, is a utility. This is a utility given for the user where they can write the codes on in their own languages. I mean, in any of the four languages which is available for the user. So there are four languages which is available. Uh, we have uh, we have Scala, R, SQL, right? And then Python. Most preferred language is PySpark, right? It is nothing but the Python over Spark. And then we have Spark SQL, right? So we can use any of the language inside the notebook. Okay, so notebooks consist of one or more cells, and each of which can contain markdown formatted content or executable code. So you can run the code interactively in the notebook and see the results immediately. Right? You can write the code, and then you can simply execute that code, and then you can see the result immediately there. Similarly, we have Spark jobs, right? So whatever code that we have written in the notebook, and we want to uh, schedule that notebook to run at a specific time, right? Or yeah, so for that we can write a Spark job. So it can be on, and that job can be executed on demand whenever you want, or you can schedule it, right? Yeah, so that file can be written in Python type, so that file can be Python, and then we can execute it as a job. Now, next unit is work with the data in a Spark data frame. So natively Spark uses a data structure called a resilient distributed data set. But while You can write code that works directly with RDDs. The most commonly used data structure for working with structured data in Spark is the data frame, right? So what what all operation do we do in Spark, right? So first of all, we will be reading the data from the source. Okay, so we'll be reading the data from the source, and then we can save that data into a data frame. And then there may be certain operations, right? Any certain transformations that we want to perform on that particular data. So all that transformation can be done, and then finally, after all the transformations, we can save that file to a particular location. So this is all, these are all operations that a user is going to do, right? uh, and that all the query statements can be written in notebook using any of the four languages which is provided for the user, right? So it will be okay. So as you can see, so loading the data into the data frame. So let's explore a hypothetical example to see how you can use a data frame to work with the data. Suppose you have following data in a comma delimited text file named product.csv. So there is a file, a CSV file which has been given to you, and then in that CSV file we have all the column names with the data, right? So we can load this data into a data frame. Okay, so below they have shown us that how we are reading the data, and also for a particular table there is a particular schema defined for that table, right? So schema is in what all columns are there, what are the and what is the data type of those columns. So it will all be there in that file. So what here we are doing is we are inferring the schema whatever is there for that particular table, right? And then we are writing the code in PySpark, right? So here with this magic, uh, um we call this 2% sign as the magic command, and then we can type, in whatever language that we want to write. So if we want to write in PySpark, we can just type PySpark after this magic command, and then we can write it, right? So here what we are doing is we are reading a file from a location, and this file uh, is stored in the data frame, right? And here we have given the format of this file and the header, which is we have kept it as true because we have the header in this particular table or in this particular file, right? And then we are saving, after reading this data, we are saving it in the data frame. So the percentage PySpark line at the beginning is called a magic and tells the Spark that the language used in this cell is PySpark. You can select the language you want to use as a default in the toolbar of the notebook interface, and then use a magic to override that choice for a specific cell, right? So in the at the top there is you can select the language, right? The default language of that particular notebook. Okay, so you can select Python, for example. Um, but then you want to write your you want to write the command in SQL or Spark SQL. So what you can do is you can simply give this magic command, uh, and then you can write SQL, and then you can uh, write the commands, right? Write the query in SQL format. So that way we can do. So here they have shown us that how we can write the command in Scala. So here we have given percentage Spark, and then we are able to write the query in Spark in Scala. So as you can see here in Scala, so there is not much difference, but yeah, we put this val here before this data frame name, and then yeah, we can write it spark.read.format. Then CSV is the format of the file, option header and true, and then load the file, then load and then the location of that file, right? So this is just the name of this data frame. As you can see, we can keep any name as we desire, so it is not mandatory that you have to give only df. It can be anything, right? So yeah, so okay, so both these code samples would produce output, same output, because we are just reading the data. But yeah, we are just using different languages for giving us the data. So here is it is. So what we are doing, we are reading that, we are saving this data in a data frame, and then we are just asking to display this data, whatever is there in the data frame, just 10 rows out of it, right? So here we are trying to show that how we can explicitly specify the schema, right? So in the above example, we have inferred the schema whatever was there in that table, but here below uh, we are specifying the external schema, explicit schema, right? So in this CSV file, we don't have the schema, and we don't have even the column names as well, right? So what we can do is we can import first of all whatever libraries that we have to, and then what we here we are doing is we are using this function struct type to explicitly specifying the schema, right? So we are given the name of the columns, right? And then we are also giving the data type of these columns. And after giving all this information, what we are doing is we are reading this file right from that location, and then here in schema we are giving this schema whatever we have just defined, and then header is not there in this particular table, so we have kept it as false, right? So this is very simple. So here we are just displaying this data frame, only 10 result out of it, right? And then you can see the output is again the same. So the pro tip is that specifying an explicit schema always improve the performance, right? And then we can also do certain transformations on top of it. We can filter the data, right? After reading it, we can further use this data frame and then do the filtering, right? Here we are just selecting two of the many columns available in that table, right? In the same way, there are different ways of doing this transformation, right? And then here what we are doing is we are chaining this transformation. So on this data frame we did one transformation by selecting only certain columns, and then again we are doing another transformation by chaining the where function here, and then we are just putting this condition that wherever the category is mountain bike and wherever the category is road bike, that we want to filter the data. To group and aggregate the data, we can use group by method and aggregate function. For example, here if you can see, we are just again doing the same, selecting only two of the columns, and then we are grouping it based on the category, okay? And then we are taking out the count, right? So ultimately the output would be the categories and then the corresponding count of those categories. And then finally we are saving a data frame. So you will often want to use Spark to transform raw data and save the result for further analysis or downstream processing, right? So you have to keep the data somewhere, you have to save that data so that the downstream application can use that data further, right? So we do use this function, write function. So df.write.mode. In mode we can give overwrite or append. So here we are writing overwrite because we want to replace the data whatever is there, and then the file format would be the Parquet file, right? So we are using the Parquet file, we are saving the file in a Parquet format, right? So in OneLake, as we said right in the previous modules, that we are using OneLake here, and then whatever data that we have in OneLake, it is in Parquet format, which is the most efficient format, right? So that is another thing. So Parquet format is typically preferred for data files that you will use for further analysis or ingestion into an analytical store. So Parquet is a very efficient format that is supported by most large-scale data analytics system. In fact, sometimes your data transformation requirement may simply be to convert data from another format such as CSV to Parquet format, right? So yeah, in most of the companies, if you go, you will see that they are storing all the data in Parquet format because that is the most efficient way of storing the data, right? And then we have partitioning the output file. So whatever files, right, whenever we are writing a file, we should uh, partition those files so that the read should be efficient. Now, why is that? Okay, we will discuss this in a short while. So, partitioning is an optimization technique that enables Spark to maximize performance across the worker nodes, right? So, what are the worker nodes? So, whatever the different machines that in which we are going to send our files, right, for processing. So, those are the worker machines. So, more performance gain can be achieved when filtering data in queries by eliminating unnecessary disk IOs. So all the processing, whatever is happening in all the different VMs, right? So that processing happens in the memory, right? So there is no unnecessary disk input and output happens. So all the processing happens in memory, which again makes the performance faster. Okay, and then what are we going to do is we save these files uh, in partitioned manner. So what does it mean by that? Partitioning, what is it? So to make you understand, just take an example of a table, right? We have a big table, and then we have one column as product category. So there are different products, right? And then suppose we have a sales data, right? And then in that sales data we also have a column called product category, right? So there are different products in that sales data, and then we also have product categories. So there can be several product categories. Just take an example, suppose there are 8 to 10 product categories, right? Because the product IDs or products can be many products, but the category can be few categories only, right? So there can be a category called apparel category, right? And then there could be some hardware category could be there, or there could be a category of anything. You can take any category. So there could be certain categories which is for which the cardinality is low, meaning there are certain categories which you can for which you can manage to create the folders, right? So partitioning in a sense is we are for a big table we are going to save the data in several partitions, right? Or I would say several folders. So just think that okay, for example, there can be 8 categories of a product or 10 categories of a product, and then we create 10 folders, and then inside each those folders, right, we have certain data. And then instead of keeping one big large file, we are dividing this big file into 10 folders, right? And now, whenever we are running a search query, right? So instead of searching any data, we can see that by applying the filter to one particular category, product category, we will only go to that particular folder where the data is kept actually. So if there are 10 categories, category 1 2 3 4 6 10, okay. So if we want to we if we are searching for a data which is in folder which belongs to category 4, so we are not going to search in any other category. So this will make our performance faster, right? So this is why the partitioning concept is very it is very important whenever we are talking about huge amount of data and then storing that data, right? So here what we are doing, we are writing, or yeah, so suppose this was the last data frame that we have, and what we are doing a further operation of writing it. So we are writing it and then partitioning the data based on the category. So this is the function or the method that we can use partition by, right? And then whatever the column name is there, so category is the column name, we can put it, and then what is the mode, we are overwriting, fast, fine. And then the file format in which we are going to save is Parquet. Okay, so what will happen is the folder names will be generated, right, whenever we are partitioning a data frame, and then the name of those columns would be, I mean the format of the column name would be like column equal to whatever values that we have. So category, right, so we have 10 categories, so whatever those categories are, so column equal to whatever that category is. So here they have given the example that there are two categories, mountain bikes and road bikes, right? So each subfolder contains one or more Parquet files with the product data for the appropriate category. So you can partition the data by multiple columns, which result in a hierarchy of folders, right, for each partitioning key. So you can create, suppose 10 folders are there for each category, and then under that category there can be certain subcategories as well. So we can create subfolders. So this will again enhance our performance, right? The only thing that we have to keep in mind is the cardinality of that column, which column, that the column that we are going to partition should be low, meaning the unique values in that particular column should be less, right? If the unique values in that particular column is less, that means the cardinality is low. If the unique values of a column is high, then its cardinality is high. So we should not do the partitioning based on the column for which the cardinality is high. Now tell me, uh, if there is a column, product ID. So do you think that we can partition the data based on the product ID? So the answer is no, because in this case the cardinality will be too huge, because there will be multiple products and for each product there will be individual product ID, right? So yeah, so we should not be, so if imagine if you are going to partition the data based on that product ID, so there will be huge amount of folders which will be created, and that will again hamper our performance, right? So whenever you are writing the select query, it will again they will it will have to um, go to so many, I mean okay, not only it will not go to the folders, but there will be so many folders, so again it will take the huge amount of size as well, I mean so when there will be huge amount of folders, then it will not be an efficient way of doing the partitioning, right? Yeah. So once the data has been loaded in a partitioned folder, we are going to read this partitioned data, right? So how we do that? So whenever reading partitioned data in a data frame, you can load the data from any folder within a hierarchy by specifying explicit value or the wildcard for the partitioned fields. For example, right. So here what we are doing, we are reading a data frame. So road bikes df. Okay, we are saving this here. So this is the name of the data frame we are saving, and what we are reading this file, this Parquet file. So files bike data, and then we are specifying that what is the category, right? So road category, so road bike. So yeah, we are specifying that in this file location itself, and then yeah, we are displaying it, right? So this is how we have to give the query, right? So let's go to the next unit. So work with data using Spark SQL, right? So we have seen that how we in Spark in the notebook how are we going, how do we write the PySpark, you know, how are we writing PySpark code? And now here we are going to write Spark SQL, right? So the data frame API is part of Spark library named Spark SQL, which enables data analysts to use SQL expression to query and manipulate data. Right, so here creating database objects in the Spark catalog. So Spark catalog is a meta store for relational data objects such as views and tables, right? So the Spark runtime can use, um, so I think um, let's, I think we can close this session, because we can cover this part in the next video, because we have already spent half an hour, and then if we continue here itself, then this video will become, you know, very big. So better to cover this topic in our next session. So I hope that you have gained some knowledge from this session, and then yeah, if you have any questions, please uh, write it down in the comment box, and then yeah, definitely I will come back and then answer your questions. Thanks for watching. Have a good day.